Hello YouTube viewers, hope you're all doing good. Welcome to this video, and in this video let's see how you can install or deploy Prometheus and Grafana into your Kubernetes cluster. Right, Prometheus is a monitoring tool originally developed by SoundCloud, and Grafana is a visualization tool. So you collect the metrics from using Prometheus, and then you visualize it using Grafana with some nice dashboards. Okay, while I'm talking, I'm going to bring up my Kubernetes cluster. CD to play directory, CD to Kubernetes, vagrant provisioning, and do vagrant. Now, I got to git clone my Kubernetes repository. So as I always do, I start up a clean cluster so that nothing else breaks. So it's always a clean cluster in all my videos. CD to Kubernetes, vagrant provisioning, do vagrant up. So that's going to provision a master node and two worker nodes. It's going to take 8 or 9 minutes. So meanwhile, we can talk about the Prometheus and Grafana stuff. Right, I'm going to be using Helm to install these two applications. I've done a video on Helm, so if you haven't watched it, please watch that video. If you want to follow along this tutorial, you need to have a working Helm a deployment in your cluster. Okay, so Prometheus is for monitoring. So why we need Prometheus? We've got other monitoring tools like Nagios, CheckMK, and lots of other tools, but they are for traditional infrastructure. Kubernetes is a very dynamic environment where you create pods, replicas, deployments, and then pods come, go, you delete a node, node gets auto-scaled, and you've also got pod auto-scaling. So it's a very dynamic environment, and the traditional monitoring tools doesn't cope very much with this particular environment. So there is this tool called Prometheus, which you can use to monitor, and we'll use Grafana to visualize the dashboard. Okay, let me bring up my notes here. So if you want to follow along this video, you have to have two things ready. One is dynamic provisioning. I've done a video on how to use dynamic NFS provisioning. So this is the nodes that I used. Basically, you need to have an NFS server and you have to export a directory. And inside your cluster, you'll have a NFS client provisioner pod running, and then we need to create the storage class. So once you do that, basically you can create persistent volume claim, and that will get bound to a persistent volume. So the persistent volumes will get dynamically provisioned for each deployment. You don't have to provision persistent volume. So that will make our life a lot easier. So you need to have dynamic NFS provisioning or any kind of dynamic persistent provisioning. And the next one is the Helm and Tiller stuff, which I did a video on that too. You can search in YouTube for getting started with Helm in Kubernetes. You need to have basically Helm binary on your workstation and Tiller component on the Kubernetes cluster, and you can readily deploy lots and lots of applications using Helm, which is very easy. Right, so that's the prerequisite, dynamic NFS provisioning and Helm environment setup. Right, so in this video what we're going to do is we're going to use Helm to deploy Prometheus first, that's for monitoring, and then we're going to deploy Grafana for visualization. We're going to deploy all Prometheus resources in its own namespace called Prometheus, and Grafana in its own namespace, Grafana. So when you install application using Helm, you can pass minus namespace equals whatever namespace you want. So that will create the namespace. But you have to bear in mind that when you delete your application, Helm delete your application, it won't delete the namespace. So you have to manually delete the namespace. You'll come to know that better when I do the demo. Okay, so Prometheus is a big one, so that's going to deploy loads of resources in your cluster. I want to clearly see what resources are deployed by Prometheus. That's why I'm deploying Prometheus in its own namespace. So it's going to create secrets, config maps, service accounts, persistent volume claim, deployment replica set parts, daemon sets, role, cluster role, role binding, cluster role binding. There are loads of resources it's going to deploy in your cluster. So when you create the persistent volume claim, as we have dynamic NFS provisioning, it's going to create the persistent volume automatically for us. That's served by the NFS server. Okay, so enough talking. Let's get into the business. Let's see where we are with the provisioning. It's still initializing the Kubernetes cluster in the master node. So it's going to do the K worker 1 and K worker 2. I think it's going to take another 4 or 5 minutes. I'm going to pause the video here and come back when the cluster is ready. Right, Vagrant has provisioned the cluster. I'm going to copy the Kubernetes config from kmaster to my host machine so that I can run the kubectl command from my host machine to interact with the cluster. Make directory.kube and sap the kube config file. Okay, we are set now. If I do kubectl cluster info, we've got the cluster, kubectl get nodes, 3 nodes, all are in the ready status. Version -- short. We are on version 113.2, so we are all good now. If I cd one directory above into my YAML, so this is where I have all my YAML files. I'll put the link to my GitHub repository in the description. And if I go to NFS provisioner, as I've provisioned this cluster from scratch, I need to set up the NFS provisioner. I've got few YAML files here. The first thing I'm going to edit is the deployment.yaml. I'm going to put my NFS server's IP address, which is this one here, 1095.65.213, and in this place as well. That's done, and one other thing I'm going to do is I'm going to edit the class.yaml. So that's the storage class. So we're going to create a storage class named managed NFS storage. The thing I need to change, I would like to change here is I need to make the storage class a default storage class because while using Helm, you can customize the values file and specify a storage class there. But if you don't specify a storage class, I want the cluster to automatically select this storage class. So that is one less editing in your values.yaml file. So I'm going to make the storage class the default storage class. So whenever you whenever you deploy a persistent volume claim without a storage class, it's going to use this storage class as the default one. So for that, I'm going to add an annotation. Annotations. If I browse Kubernetes default storage class, change the default storage class, and the thing you need to add is this one here. Is default class equals true. Paste that. That's an YAML. Okay, and paste that. Okay, so that's done. If I do kubectl get all, nothing. Kubectl get storage class, nothing. Let's deploy all these 3 YAML files. Kubectl create -f rback class.yaml default deployment.yaml. Okay, so that's all done. If I do kubectl get storage class, you will see this bit here, default. So that says that's the default storage class. Okay, so that's done, and we need to set up the tiller. I've already got Helm installed, I need to install the tiller component because this is a clean cluster. We need to create a service account in Kube system namespace called tiller, and we need to create a cluster role binding. Okay, and if I do kubectl -n kube system get pods, tiller, I haven't initialized the tiller. So helm init service account tiller, and if I do that, it says the tiller, the container is getting created. Container is getting created. Okay, let's wait for a moment. That's running, but it's not ready yet. Okay, so tiller is ready. If I do helm list, I haven't got any applications installed. So the first thing we are going to install is Prometheus. kubectl get namespace. So as you can see, there is no namespace for Prometheus and Grafana. So you don't have to manually create the Prometheus and Grafana namespace. We can tell the helm install command to create that for us. So first we need to download the values file, helm inspect values stable Prometheus. If you want to search for Prometheus, helm search Prometheus. So there are lots of Prometheus, but we're going to install this one here. If you search for Grafana, you have just one version, one chart for that. Okay, so let's download the values file. Stable Prometheus, and redirect that to a temporary file. Prometheus.values. Okay, let's edit that file. If you see here, it's a very big file. So it has got like 1,174 lines. That's a very big file, but what I'm going to do is it creates lots and lots of services, but the one thing I need to change is I need to make it run on node port 32322. By default, it will the service won't be exposed, or it will be exposed within the cluster, but we need to expose the service to the outside world. So if I search for server, so that's the server, Prometheus server container. And now if I search for type, okay, there it is. Type is cluster IP. I need to change that to node port. It is case sensitive, so you need to make sure you type in the proper case. And node port 32322. So that's all I'm going to change. And if you search for persistent, so there's one persistent volume for 2 gig, and there is another persistent volume for 8 gig. So it's going to create 2 persistent volume claims, and the persistent volumes should get dynamically provisioned. Okay, so we are good to go. Now let's install Prometheus application. Helm install stable Prometheus, and let's give it a name, otherwise it would generate a random name. Prometheus values temp Prometheus.values file, and namespace Prometheus. Okay, so cool. It's deployed, and if I open up a new pane, and if I do watch kubectl get all minus namespace Prometheus. So these are all the resources. It's running, and there are some pods. It's fetching the container, and we've got lots and lots of services. So that's the Prometheus server service. Node port, so we changed that to node port, and we specified 32322 for the port. It has also created a daemon set Prometheus node exporter. Basically, that bit is the bit that sends the metrics collected from each node to the Prometheus server. So it has to be a daemon set. So I've did a video on daemon set. Daemon set is a deployment that you install on all the nodes in your cluster. So that has to be daemon set because the node exporter needs to be running on every single node in your cluster. So all of them are running, and there is one deployment that's also ready now. Okay, so let's close that and do kubectl get namespace, and you can see it has created the Prometheus namespace for us. Okay, let's see what it has done with the persistent volume climb. Kubectl get pvc. There's nothing, but we have to check that in the Prometheus namespace. As you can see, there are two persistent volume claims. It is already bound to the persistent volumes, 2 gig and 8 gig, and it has used the managed NFS storage. So we haven't changed the storage class. We haven't defined any storage class, and since we made this storage class the default, it has actually used it. kubectl get pv. Okay, those are the two persistent volumes that got provisioned dynamically. And if I do ls srv nfs kube data, so that's the exported nfs directory from my nfs server. And you can see two directories that got created for these two persistent volumes. Okay, there's one other thing I want to show you. If you didn't have a dynamic NFS provisioning, you would have to create the persistent volume yourself. Or if you haven't set the storage class you created to the default one, you have to edit the prometheus.values file and change the storage class to managed NFS storage. We didn't have to do this because it's going to use whatever the default storage class is. If you didn't set that storage class to be default, and if you don't specify a storage class here, your deployment will be in pending state waiting for the persistent volume. Okay, so let's go ahead and check kubectl get all -n Prometheus, and the server we are going to access is on port 32322. It's a node port, so you can access it from any of your nodes. Okay, let's check that out. kworker 2 32322. Okay, so that's the Prometheus dashboard. Let's see if we can find something. So there are lots of metrics being collected. Let's check something. Node, CPU cores. There are lots of fields. Guest seconds total, for example. Execute. Graph. It didn't have any values, so it's just showing the default graph. If I change that to something else, node load 1, for example, execute, and you can see those graphs. But we're not going to use Prometheus. It's just for debugging, and we can use this is just to show that you can also do the graph in your Prometheus dashboard, but we've got a specialized tool for it, Grafana, for visualizing dashboards. Okay, so that's Prometheus. Let's go ahead and install Grafana. kubectl get namespace. We don't have a namespace for Grafana, but we can use the helm install command to create that namespace. Helm inspect values stable Grafana. Pipe that to a temporary file, grafana.values. Edit that file. So it's creating role-based access control RBAC, service account is enabled, one replica, deployment strategy. What I want to change in here is, let's see, priority class, annotation service. Okay, so that's what we need to do. Let's change the type cluster IP to node port. and set the node port to 32323. Resources, node selected, is all looking good. Persistence, so it's going to create a 10 gig volume, and I haven't set any storage class name, so storage class is default, so whatever the default in your cluster, it's going to use that. Admin password, okay. So anyway, if you do helm install, the log will show you how to get your admin password. But if you want, you can set your password here. This is admin password. So that's my admin password. That's all I need to change. This is also a big file. So we have 318 lines in it. Okay. So let's install that now. Helm install stable Grafana minus name Grafana minus values temp Grafana dot values minus namespace Grafana. Okay, cool, that's done. I need to delete that because it says persistence is disabled. You will lose your data when the Grafana pod is terminated. Okay, let's delete that and reinstall it. Helm list. So Grafana is running kubectl get all minus n Grafana. It's creating the container at the moment. Let's wait for the container to create and then we can delete it. Okay, so that's running. Helm delete Grafana minus purge. Let's edit the Grafana.values, and where it says persistence, let's search for persistence. There you can see by default persistence is disabled, so when you restart your Grafana deployment, when you kill your pod and if it restarts, it's going to lose all the settings. So let's enable it. And now if I do helm install the same command, and you won't see that notes here. Watch kubectl get all minus n Grafana. Pod is initializing at the moment. It's running and it's waiting. It's not yet ready. Excuse me. Okay, so while it's it's ready now, and let's look at the persistent volume claim. So that's the persistent volume claim, and it's bound, and it has created a persistent volume for us with 10 gig managed NFS storage class. LSSRV NFS cube data, so there are now 3 persistent volumes that got dynamically provisioned. kubectl get all minus n Grafana, and that's the service that we are going to access. It's a node port service running on port 32323. So we're all good to access the dashboard now. We can access it from any of the worker nodes. So let's go and check it out on kworker1 32323. What? Okay. kworker 2 32323. Okay, for whatever reason it's not working on kworker1. I think the node might be busy. Okay, so the username is admin and the password is we've hard-coded the password in the values file. This is admin password. Okay, so we are now logged in. So by default the Grafana dashboard is empty. We haven't got any dashboard. The first thing we need to do is we need to add a data source. So if you click add data source, there are a few options to choose, and we're going to go with the Prometheus because we've got the Prometheus in our cluster already. Click that. What's the name of the data source? Let's name it Prometheus, and the URL is http kworker2:32322, and you have to change the access from server to browser. And now you can do a save and test. Okay, data source is working, that's cool. And now we can go to home. There are no dashboards. You can create a new dashboard. For example, graph. Let's edit the default graph. Data source, let's select Prometheus. And if you start typing, it will show up what are all the metrics you've got access to. Okay, node, CPU, disk IO. Let's see if you've got load values. Okay, so load 1 is there. And if I press enter, no, it's okay, there you go. So you've got some data. So you can go ahead and keep on customizing how you want your graph to be displayed, but that's not how I want to do, because there are good people, they've already created nice looking dashboards for us. If you go to Grafana dashboards, if you search for Grafana dashboards, you can select a dashboard. So to select a dashboard, you need to select the data source. So what type of data source? Select Prometheus. Panel type, whether it's a chart, log, all type of panels. So let's leave that to default. Category, collector. So we've got the node exporter, collectee, and so on. So let's leave that to all. Okay, so that has already given us some dashboards. So let's see which one we can pick. So there are lots of dashboards here. So this one here, the third one looks good. If you click on that, so that's a Kubernetes deployment stateful set daemon set metrics dashboard. And if I click that one here, it should look something like this. Okay, so how do you install this dashboard? So you need to get this dashboard ID, which is 8588. And if we go to our dashboard, we can click on this plus icon and click import discard, and here you need to type in the dashboard ID 8588. If you've got a JSON file for your dashboard, you can upload it, or you can type the JSON file, but it's easier to use one of the existing ones. So once you import that, you need to select the data source. Select the Prometheus data source. So we've got the Prometheus data source which we created earlier, and import. There you go. So that's our dashboard. Deployment. So memory usage, how much memory our cluster is using at the moment, how much CPU it's using. Are there any replicas that are in the unavailable state? So we've got like 17 replicas. What's the CPU usage like? And if you want, you can filter it by individual pods. So for example, the Kube API server pod is using 0.250 and so on, and that's a nice dashboard. So here it is, the memory usage, and you have got all the pods here. If I check the tiller pod, how much it's using, and the usage is going down. So that's the maximum it has used, 93.19, and if I scroll in here, 93.19, and currently it's using 42.6 meg. Yep, 42.6, and that's showing for the last 3 hours, and now it's 11 o'clock and it's showing from 8 till 11, and you can change that here. There's all sorts of things you can do for the last 2 days, last 7 days. These are all presets. Yesterday, day before yesterday, today, this week, this month, or you can do a custom from one to refreshing every. So if you want, you can have it refresh every 5 seconds. Click apply, and it's gonna refresh. Disk usage, network I/O. We haven't got any data points for it. Cool, so that's your dashboard, and I think you can also filter it here. So these are all the deployments. So we've got the Grafana deployment, tiller deployment. For example, if I select the tiller deployment, you can filter it, how much memory it's using, CPU, and all these details. So let's look at the Grafana itself. It's not using that much CPU. Okay. And if you want to delete your dashboard, you can click on this gear icon, click delete, delete, that will be gone. And if you want to deploy another dashboard, search for the dashboard, node exporter, host metrics, and check this dashboard 9096. Let's try how that one looks. Is it 9096? Yep, 9096. The data source is Prometheus. Import, overview, what? Hosts all, that doesn't seem to be working. Let's delete that. Delete, delete. Okay, cool. This is just a starting point, like getting started video for, you can always customize the graphs the way you want it. Okay, right, let's do the cleanup before wrapping it up. kubectl get all -n Grafana, and let's delete it. Helm delete Grafana --purge. kubectl get all -n Grafana. You haven't got any resources. kubectl get all -n Prometheus. There are lots of things. Helm delete Prometheus --purge. kubectl get all and Prometheus, so it's all getting terminated. Okay, so it's all, the pods are getting terminated. It's all gone now. If you do kubectl get namespace, as I said earlier, the namespaces won't get deleted, Prometheus and Grafana, so we have to delete those. Helm list, we haven't got anything. kubectl get pv, no pv, ls srv, nfs kube data, so all the persistent volumes have been automatically deleted because the retain policy is set for delete. So when you delete the persistent volume claims, all the persistent volumes associated will also be deleted. So that's all gone now. So the only thing left is to delete the namespace. Delete namespace Grafana and kubectl delete namespace Prometheus. Cool. It's all gone, and I think I've covered everything. That's all for this video. Cool. I think this video was useful. If you find this video useful, please share it with your friends and like it. And if you haven't already subscribed to my channel, please subscribe it. And I've got a few more videos planned in the coming weeks. Right, and if you don't understand any part of it, or if you're following along and if something is not working quite the way it should, please leave me a comment. I should be able to jump in and help you. Cool, and once again, thanks for your time watching this video, and I'll see you all in my next video. Bye bye.